Okay, so this is our last video for the practice worksheet. We're writing equations in standard form for polynomials of least degree with rational coefficients, leading coefficient of 1, and the given zeros. And we're all the way down here now at number 18. And x is equal to plus or minus 4i, each with multiplicity of 2. And so I have an x plus 4i and a factor of x minus 4i, but each of those factors has multiplicity of 2 because those are double roots. Okay, and then just like in number 16, right, when we had a very similar problem, we saw that these were two difference of squares, and so we could use that difference of squares shortcut in order to combine these quickly. And so we would square the first, that's an x squared, square the last is 16i squared, but I squared is -1, and so that instead of x squared minus 16i squared, we have x squared plus 16. Okay, but we have two of those, right? So another x squared plus 16 since there's multiplicity of 2. Okay, and then we're going to combine these by foiling first, outer, inner, and last. X squared times x squared is x to the 4th. X squared times 16 is a plus 16x squared. Then in the middle, 16 times x squared is another 16x squared, and 16 times 16 is 256. And when we put that in standard form, then we'll combine like terms here in the middle and have x to the 4th plus 32x squared plus 256. Okay, so now when we do the bonus, to get this factor from x equals 2 plus or minus the square root of 5i, I'm going to first recall that if I have x equals 2 plus the square root of 5i, and I want to change this 0 into a factor, I subtract everything over to the side with my x. So this 2 here I would subtract and get x minus 2. The square root of 5i I would subtract and have minus square root of 5i. And that would equal 0 then. So that would be my factor. So y equals x minus 2 and then minus the square root of 5i. Okay, then if I change this from 2 plus the square root of 5i to 2 minus the square root of 5i, I'm still subtracting over the 2, but now I'm adding the square root of 5i, and so that would be a factor of x minus 2 plus the square root of 5i. Okay, and this, the reason this is a bonus is because in all of these other examples we had differences of squares. This one, students generally struggle to see that this is still a difference of two squares. If you look at your trinomials here, both of them have an x minus 2 here in the front, right? And then there's our plus and minus, right, our opposite signs, followed by the square root of 5i. So this is still in that same form like we had, for example, up here, x plus 4, x minus 4, right? We recognize that as a difference of two squares because the same terms, a and b, right, only in the binomials, one's a plus and one's a minus. So when you look at this example and the bonus, see how we have the same terms, a and b, x minus 2, and then a plus and minus, and then the same terms here for the b, the square root of 5 times I. So when I use my difference of squares shortcut, because this is a difference of squares, right, I square the first, which is x minus 2, right, and that gets squared. And then I have a minus because it's a difference of squares, and then I square the last term, and that's a square root of 5 times the square root of 5 is 5, and then I times I is I squared, and so that's going to be a plus 5. Right? And if you didn't quite catch that, you can go ahead and rewind the video, watch that again, or you can, if you want to do a lot of algebra, you can FOIL this all out and you're still going to end up at the same answer in the end. So now we see that this is a perfect square trinomial, right? I have x minus 2 times another x minus 2. That's a perfect square trinomial. If you remember that shortcut from Algebra 2, right, we square the first term, we square the last term to get the constant, and then in the middle we multiply and double. So 2 times x doubled is 4, and the sign is a negative, so negative 4x. So x squared minus 4x plus 4, and then our constant of 5 back here at the end is x squared minus 4x plus 9. And that would be our polynomial that has zeros, 2 plus the square root of 5i and 2 minus the square root of 5i. And because those are imaginary zeros, right, this parabola does not touch the x-axis.